video. So let's continue the second part of this series. So now we will be looking through each one of the circuits and important components and labeling of each type of combination circuits, connections. So now let's look at the YY connected connection three-phase system. YY means a recap. YY refers to Y generator connected to a Y connected connection load. So if you look here, the generator part, as I said in the previous video, if you haven't watched my previous video, please watch my previous video first so that you can have a much better understanding on the flow. The A I usually label as uppercase letter for the generator part, where capital A represents for the first phase, a single first phase of the three-phase system in the generator. Capital A, and the center will be N. Why do I label as N? You can label as any alphabets on the outer side. A, B, C can be any alphabets as long as you don't get confused. But at the center, you can't use any other alphabet besides N. Why so? Because the N, the center part, is considered as the neutral. In this case, I haven't drawn yet, but usually it is advised to draw where we connect a neutral line from the generator to the load, where we have to use the alphabet N to indicate it is a neutral. So if you look here, it's supposed to be connecting to the center, If you look here, the point A, the node A, alphabet A connects to capital N, capital A to capital N. This shows a potential difference. The N is actually acts like a ground, isn't it? So when there is a ground connected to a load or ground connected to a supply, this produces a voltage difference, isn't it? Potential difference. Therefore, the potential difference between A and N is AN across the supply. Here we use the alphabet E, potential difference at the supply. We use capital E. Whereas for the load, we use V, which is VAN. In this case, it's lowercase a and lowercase n. Because I label it so. I label the load node as lowercase a and the node of neutral as lowercase n. Therefore, the voltage across the load is VAN. Understand? Alright. So now let's look at what does it mean, IAA. Before we go into IAA, let's look at IAN first. So if there is potential difference, for sure there is current, right? So the current flowing through this part here is known as, of course, if it is EAN, then the current becomes IAN. That's it, simple. How about the IAA here? What does it mean? Before that, let's look at the load. If there is current going out, IAN, the current coming through into the load becomes IAN as well. But then this one is a lowercase IAN. That one is uppercase IAN. This one at the load is lowercase IAN. How about this IAA? What does it mean? This one is line current. So IAA refers to line current in between the generator and the load. In this case, there's no load in between, in the middle of the generator and load. Therefore, the current won't be affected because there's no voltage drop, there's no power loss in any form. Therefore, the current of the supply at the generator all the way to the load, the current is same because there's no loss. If there is resistance or any sort of impedance in the middle, it will cause power loss, therefore the current will change. But in this case, IAA will be, theoretically, the IAA will be equivalent to IAN, also will be equivalent to IAN, capital IAN, and also small IAN, lowercase IAN. It's the same thing. Why? Because there's no power loss. There's no loss in any form. Okay, let's go. Okay, this is a dissected form of this three-phase system. These here have three phases. If we took out one phase from this three-phase system, we will get this circuit. This one shows a much better visual representation of the system there. If we look here, we can see this one is the source, isn't it? So this one is the source. The power drop, voltage drop from the node A to the neutral will be EAN. Potential difference between node A and the neutral point is EAN, whereas the potential difference between node A, lowercase a to the neutral line is VAN. Alright, so the IAN is the current at the generator. IAN, capital IAN is current at generator, whereas lowercase IAN is current at load. The IAA at the middle is the line voltage. IAN is the line current between generator and the load. In this case, there's no voltage drop or any sort of power loss in the wire. Therefore, there is no change in the current. Therefore, IAN will be equivalent to IAN will be equivalent to IAA. I hope you understand. If you don't, please pause and watch it back again. Alright, so now let's look at delta-delta connection. So this one is really important things to be considered. Line voltage and line-to-line current or line-to-line voltage. So before that, let's look at the previous concept that I've mentioned in the video. For the delta connection, the nodes plays a vital role to indicate, and the power source plays a vital role to indicate the current flow. Okay, usually the power or the current flows out from the generator, it enters into the load, isn't it? That's the concept. Okay, so it's always out from the generator and enters into the load, isn't it? So now let's look at it. So when it has to go out from the generator, means the supply should be this way. So the arrow should be pointing towards A, B to A. So it is VAB. It should be flowing from C to B. So this should be VBC. And from A to C, therefore, it becomes VCA. Right? Same thing goes here. The current flows, it enters into the node A to B, so it becomes VAB. It's exactly the same, okay? So it goes the same for the current as well. IAB, IBC, and ICA. In the case of delta connection, there's no such thing as IA, IB, IC. It's always a couple, like it's like a pair. IAB, BC, or CA. It's always like that because it's connected. Alright? So the line voltage is always IAA, IAB, IBB, ICC. Line to line voltage. What is line to line voltage? It sounds different, no? Right, so the line to line voltage shows the voltage, sorry, there is two things, line to line voltage and also line to line current. But in this case we just cover line to line voltages. Line to line voltage. What is line to line voltage? Voltage drop between a line to another line. So in this case, this one is a line representing A. So this one is a line representing the B. So in this case, if you want to measure VAB, it means from A to B. Okay, I give another example. Maybe in this in different circuit. Maybe this circuit, the previous circuit. Let's say if I want to show a VBC, I want to see a voltage drop between line B and C. Line B is beneath here and C is up there, so it should go from bottom to up, down to up. Okay, how about in this circuit? It goes from B to C. In this case, B is higher than the C, so you draw from B to C. Okay, this one is a much better example, and it also can be considered as a tips, where you don't have to really go through all the notes, just understand what I am showing you here. Where VAB means, you just separate the letter A and B. Means the A going towards B, means the point should start from A towards B. Anywhere, if the A is here, the B is here, then connect A to B from down to up. If the A is here, B is here, then it should go from up to down. Okay, top to bottom. So that's what is here. In this case, the VAB, line A is on the top, B is on the bottom. So VAB means the arrow should start from top all the way to the bottom. How about VCA? In this case, the line C is at the bottom, so you should start from the bottom towards up. So it's B, C to A. So that's how we actually calculate the line voltage. Okay, VAB, VCA, and so on. Alright, so I will give another tips in the upcoming video, so please stay tuned to watch the rest of the video in the series, and it will definitely help you to understand in a much better way. Thank you.